Hi everyone, today we're going to be talking about angles. An angle has two sides and a vertex. The sides are both rays and the vertex is their common endpoint. So here's an example. Here are the two sides that are rays YZ and YX, and here's the vertex Y, which is the common endpoint of both rays. So to name this angle, we use this symbol here, and there are a number of ways we can do it. We can name it simply by using the endpoint at the vertex, so it would be known as angle Y, or we could use the points on the rays and the vertex, making sure that the vertex point is in the middle, so we could have an angle XYZ, or the other way around, angle ZYX. Or sometimes the angle is given a symbol, which might be a number or a letter. So we could call it angle 1. All angles are measured in degrees, and we use this little circle to indicate degrees. And protractors are used to measure angles. So some of you may have seen a protractor before, and you'll be using these in class. And to use a protractor, there are a few steps you need to take. So here we have an angle G, or angle HGI. And to measure it, what I'm going to do is, on your protractor you'll find a center point that is marked by either a little hole or maybe a line like this one. You may not be able to see it clearly from where you are, but you'll have a chance to practice with these in class. So what I do is I place this center point on my vertex, and then what I'm going to do is line one ray up with 0, and there's a 0 on both sides, so it doesn't matter which ray you use. In my case, I'm going to use this ray and line it up with 0. So my center point goes on my vertex, and I make sure that this ray GI is lined up with 0 on my protractor. And the next step for me is to take the measurement from the position of the other ray. So I look where this other ray is extended, and it meets 60 degrees on my protractor. So now I know that the measurement for angle HGI is 60 degrees. Obviously, there are many different types of angles, so how do we classify them? Angles can be either acute, right angles, obtuse angles, or straight angles. Acute angles are less than 90 degrees. They look something like this. Right angles are exactly equal to 90 degrees. So they have a line that goes straight out to the side and one line that goes straight up depending on its orientation. Obtuse angles are greater than 90 degrees, so they're more open than what a right angle would be. And straight angles are equal to 180 degrees, or in other words, a straight line. Lines that intersect to form right angles are called perpendicular lines, and here's an example. We have line AB and line CE, and they're intersecting to form a right angle. The symbol here is the symbol that we use to show that it's a right angle. So let's take a look at complementary and supplementary angles. If the sum of the measures of two angles is 90 degrees, then the angles are complementary angles. So here we have angle 1 and 2, and we can see that they form a right angle. Angle 1 is equal to 58 degrees, and angle 2 is equal to 32 degrees. And combined, they have a total measurement of 90 degrees, which makes them complementary angles. If the sum of the measures of two angles is 180 degrees, the angles are called supplementary angles. So here we have a straight line, and angle 1 and angle 2. Angle 1 is equal to 45 degrees, and angle 2 is equal to 135 degrees. So combined, they have a total measurement of 180 degrees, which means they are supplementary angles. There are also some special pairs of angles that we need to be able to recognize. Vertical angles are formed by two intersecting lines, and as you can see here, I have two intersecting lines. Vertical angles have equal measures. So in my diagram here, my two intersecting lines form 4 angles. Now, the angles that are opposite each other in my intersecting lines are the ones that are vertical angles. So angle 1 and 2 are vertical angles, and angles 3 and 4 are also vertical angles. So angle 1 is equal to angle 2 because we know that vertical angles have equal measures. And similar with 3 and 4, angle 3 is equal to angle 4. They have equal measures. Angles with equal measures are congruent angles.